All right, IM3 classes. Today we're starting our unit on factoring polynomials. Uh, Today we're going to talk about factoring using the greatest common factor, and we're going to do factor by grouping. Just real quick, I want to explain what we mean by factoring. When you factor something, you're breaking a quantity down into smaller quantities that multiply together, get to the original. So simple example, let's say we had a number 10. I want to factor 10. 10 factors into 2 times 5. All right, that's it. So the factors of 10 are 2 and 5. All right, sometimes you have larger numbers. So say we had something like 12 that has more than 2 factors. So 12 can factor into 2 times 6. And then 6 then factors again to 2 times 3. So 12 has 3 factors, 2 times 2 times 3. All right. So what we are going to be doing is factoring polynomials. We're going to start basic with binomials. We're going to factor this into 2 smaller quantities that multiply together. Get it? For this first time, it's going to be a monomial and a binomial are going to be the 2 smaller factors. How you want to do this is you want to look at each term and find the greatest common factor. So what do these 2 terms have in common? You have done this before. We've done it in class before. It's similar to like reducing fractions. You're trying to find the largest thing that divides both 9 and 15, or 9x squared and 15. A lot of you can do it in your head. That's fine. If you don't do it in your head, what you're going to want to do is do a factor tree on the numbers. So 3 or 9 factors into 3 times 3. 15 factors into 3 times 5. What I'm going to do is I'm going to write these out. I'm going to put these in parentheses. So 9x squared is going to be 3 times 3. I'm going to expand the x squared to x times x. Minus 15 is 3 times 5. All right. Then what you want to do is you want to look for what the 2 terms have in common. So they have 1, 3 in common. Right. For every factor they have in common, one of those goes on the outside here. All right. And then just multiply things back through. So I have a 3 on the outside. Then 3 times x is 3x squared minus just a 5 left over. So you're going to take out what they have in common. So this is the GCF, the greatest common factor. This is what's left over after we factor it out. So more simply, if we were to do a factor tree on the binomial, this whole quantity, it factors into 3 times 3x squared minus 5. So those are its 2 factors. Right, so this is the answer here. Another way to think of this is reverse distributing. All right, we are undoing the distribution property. If we were to distribute the 3x squared back, or the 3 back into the parentheses, 3 times 3x squared is 9x squared, 3 times 5 is 15. So we are undoing the distribution property with factoring using a GCF. So let's do another example. So here, only a 2. A 2 is a prime number, so we don't need to do a factor tree on that. I am going to expand the ends. So this first number is going to be 2 times n times n times n plus n squared is n times n. And I look for what they have in common. So they have an n in common. They each have an n. So I'm going to put an n on the outside. And then they have another n. Share another n. So I'm going to put another n on the outside. Nothing else left in common. And so I'm going to multiply through. So n times n is n squared. On the outside, inside, this is 2 times n left there. So 2n plus, if there's nothing left over, so we took out all the factors from the second term, there's always a factor of 1. So there'd be a 1 left over there. So we took out n squared. We're left with, so n squared times 2n plus 1. Again, this is something you could do in your head, no problem. You are undoing the distribution. Let's look at an example with both numbers and variables. So we have 14. 14 factors into 2 times 7. 16 factors into 2 times 8. As you get good at this, you can probably notice that we can stop right there, but I'm just going to factor this fully. 8 is 2 times 2. Nope, it's not. It's 2 times 4. 4 is 2 times 2. So I'm going to expand this. So 14 is 2 times 7. And then I have 5x is 1, 2, 3, 4, 5. Plus 16 is 2 times 2 times 2 times 2. And then I have 4x is 1, 2, 3, 4. So this is 14x to the 5th, 16x to the 4th. And now let's just look for what they have in common. They have a 2. Take out a 2. And then they have a bunch of x's. This one, if I look at the second term, I'm going to simplify this a little bit. It has 1, 2, 3, 4 x's over here. 1, 2, 3, 4 x's over here. So they have 4 x's in common. So I can take out 4 x's. That'd be x to the 4th. All right. So I take out all 4 here and 4 from the 5. Now I just write what's left over. Rewrite this. So x to the 4th times 2. You more likely see that 2x to the 4th times 7. X is left right there. Plus 2 times 2 times 2 is 8. And no x is left there. So 2x to the 4th times 7x plus 8. Again, do it in your head. If you're good at it, you can just take out that 2x to the 4th right away if you recognize the greatest common factor. One more. We're going to do a little bit bigger numbers. So 72. That is even, so I know that's going to have the 2 as a factor. So that's 72 is 2 times 36. 36 is even again, so I know another factor 2. So 36 is 2 times 18. 18 is 2 times 9. 9 is 3 times 3. 27 is 3 times 9. And then 9 is 3 times 3. So I have all the prime factors there. Multiply out. So I have 1, 2, 3 2s, 2 3s for the 72. So 2 times 2 times 2 times 3 times 3 times x. Don't forget the x in there. And then 27 is 3 3s. And then I'm going to look at what they have in common. And I'm going to kind of do a shortcut here. This one doesn't have any 2s, so I can ignore the 2s. It has 2 3s. So they have 2 3s in common. So I'm going to take out 2 3s. Multiply that out. 3 times 3 is 9. 2 times 2 times 2 is 8. And I have an x plus 3. So there we go. Next, we're going to do factor by grouping. Ooh, now we have 4 terms instead of 2. We're going to do a lot of factoring using the greatest common factor. So from here, I'm going to do the greatest common factor in my head instead of showing all these steps. If you need to show all these steps, go back in the video. You can check it out. But from here, I'm going to do the greatest common factor in my head. All right, so first thing, what you want to do is call it factor by grouping. So what you want to do is group the first 2 terms together and the last 2 terms together. And then you are going to do a greatest common factor on each of these. So I'm just going to look at this first grouping. Greatest common factor between 3n cubed and 2n squared is just going to be n squared. Expand it out, pull things out if you need to. But what's going to be left over in there is going to be 3n minus 2 left over. Plus 3n minus 2. 3n minus 2, there's no common factor there. what you need to do if they don't share a common factor, you need to take out we're going to say it's a 1. All right. And then it's 3n minus 2. So remember, the greatest common factor is undoing distribution properties. So if we distribute a 1 in here, it doesn't actually change. So if there's no greatest common factor, we're going to say we take out a 1. Next, what you want to do is regroup things. So I'm going to group the greatest common factors together, those numbers in green, into one set of parentheses. So it's going to be n squared plus 1. And then it's going to be, you only need one of the blue groups. So 3n minus 2. All right. So what we are doing is undoing a split and distribute method of multiplying binomials. So if you remember, if we were going to go backwards and multiply these together, if you split up this first one and distribute each, so split up the n squared plus 1 and then distribute each into the blue binomial, it comes up here. So we're undoing the multiplication. So this up here factors into here. So let's look at another example. So group terms together, the first two terms together, and the last two terms together. And then you're going to look for a greatest common factor. So here, the greatest common factor between 9n cubed and 3n squared, I can take out a 3 between the 9 and the 3, and an n squared between the n cubed, the n, and then I'd be left with, so 9 divided by 3, that I'd be left with 3n. I took out the whole n squared, so it's going to be plus 1. So if you take out the whole term, the greatest common factor of the whole term, you still leave a factor of 1 in there. And then plus 6n and 2, they have a greatest common factor of 2. And then I'd be left with 3n plus 1. Group the green terms together. So 3n squared plus 2 times 3n plus 1. And that is it. So let's look at another example. Last one here. So again, group the first two terms together and the last two terms together. Find the greatest common factor of each of these groups. So 8a cubed minus 10a squared. The greatest common factor between 8 and 10 is going to be 2. And a cubed and a squared is going to be a squared. So 2, this is going to be 4a minus 5. Oh, I wanted to do that in blue. It'll be left over. So once I identify the greatest common factor here, it's just a matter of dividing these by the greatest common factor. If you're not doing the whole factoring out, taking out what they have in common, you just divide. So 8 divided by 2 is 4. A cubed divided by a squared is a. Minus 10 divided by 2 is 5. A squared divided by a squared is 1. So we just leave it as 5. Plus 20a minus 25. So that's going to be, greatest common factor is just going to be 5. So 20 divided by 5 is 4a, 5 divided by 5, or 25 divided by 5 is 5. One thing I forgot to mention, the last one, easy way to determine if you are doing it correctly. These should match. The parts in blue, after you do the greatest common factor, what's left over, those parts in blue should match. If they don't match, there's two possibilities. One, it does not factor, or 2, you made a mistake. It's most likely 2, so you need to go back and check your work. If they're not matching, it's most likely you made a mistake taking out the greatest common factor. So you need to go back and check your work. I'm not going to give you a lot that don't factor. I might give you one or two here or there, but most of them are going to factor. So if they don't match, check your work. But since they do match, we're good to go. You have 2a squared plus 5, and then times 4a minus 5. And that will do it for this lesson. Next time we're going to be factoring trinomials.